Hello, this is video number 2 for Professor Pastor's Materials for Industry class at Tidewater Community College by Mariella Manipol. Today I am doing a presentation on the metal cobalt. So here we have where cobalt is found on the periodic table. As we can see, the atomic number is 27, the symbol is CO, and here's the electron configuration. So some properties of cobalt. The melting point is 2,723 degrees Fahrenheit, and the boiling point is 5,301 degrees Fahrenheit, and it has a hardness of 5. Let's go into a bit of a history of cobalt. So in ancient times, cobalt compounds were unknowingly used by ancient civilians to create blue pigments in glass and ceramics dating back thousands of years. In the 16th century, miners in Europe found mysterious ores that gave off toxic fumes when smelted but yielded no valuable metals. They blamed kobolds, mythical underground goblins, hence the name cobalt. In 1735, Swedish chemist George Brandt isolated cobalt metal for the first time and proved it was responsible for the blue color in glass, not bismuth, as previously thought. This made cobalt one of the first metals discovered in modern chemistry. In the 19th and 20th centuries, cobalt gained industrial importance in dyes, metals, and alloys, especially during the World Wars for military equipment and aircraft engines. In the 21st century, demand for cobalt surged with the rise of rechargeable batteries for smartphones, laptops, and especially electric vehicles. I would say that cobalt is mostly used for power, to power up things. And as I'm sure some of y'all were curious of what a cobalt would look like. So it is metallic gray in its pure form, bluish in its compound form, and it is a byproduct of copper and nickel mining. The Copper Belt in Central Africa is a major source of cobalt. This is a region on the border of northern Zambia and southern Democratic Republic of Congo. Let's dive into some uses of cobalt. So we have batteries, superalloys, hard metals and tools, and catalysts. Batteries, which are used in smartphones, laptops, tablets, what have you. Cobalt provides battery stability, energy density, and longevity. In superalloys, it is used in jet engines, gas turbines, and it can withstand high temperatures and corrosion. In hard metals and tools, when combined with tungsten carbide, it is used to make cutting tools, drills, and wear-resistant parts. For catalyst, it is used in petroleum refining and chemical production. For example, the Fischer and Tropsch process. Some more ways cobalt is used in magnets, medical and radioactive uses, and lastly, pigmented coloring. In magnets, there are cobalt-based magnets, which are used in electric motors and electronics. For the medical and radioactive use, cobalt-60, a radioactive isotope, is used in radiotherapy for cancer treatment and sterilization. Lastly, in pigmented coloring, it is historically known to be used for its blue in glass, ceramics, and paints. Here are some photos of how cobalt is used. As we can see in the batteries, used for its power and rechargeability. This vase for the pigment. And for this ring, it is the metal aspect of cobalt. Let's dive into the manufacturing process of cobalt. So the manufacturing process of cobalt is fairly involved and can be broken down into extraction, concentration, refining, and shaping into usable forms. Mining and extraction. Most cobalt comes from copper cobalt ores in the DRC, Democratic Republic of the Congo. Some comes from nickel-bearing laterite ones in Indonesia, Australia, what have you. It is a byproduct in nature. When copper or nickel is mined, cobalt occurs in smaller concentrations and is separated during processing. Ore processing and concentration. For copper cobalt ores, sulfides, the ore is crushed and ground. It goes through froth flotation to concentrate cobalt minerals along with copper. For laterite ores, nickel-rich, they undergo high-pressure acid leaching, also known as HPAL, with sulfuric acid to dissolve cobalt and nickel. Impurities like iron and aluminum are precipitated out. Separation from copper and nickel. After leaching or flotation, the solution contains a mix of cobalt, nickel, copper, and iron. Several steps are used to isolate cobalt. Solvent extraction. Specific organic solvents pull out the cobalt ions. A tongue twister. Ion exchange or precipitation, as cobalt hydroxide or carbonate, can also be used. Copper and nickel are removed first, leaving cobalt-rich solution. Refining into pure cobalt. Electrowinning, which is a common method. Cobalt ions. Sorry, I've been saying the word ion for a long time. Cobalt ions are in solution are plated onto stainless steel cathodes using electricity. This produces high purity cobalt metal sheets. Chemical reduction. Cobalt compounds like cobalt oxide or cobalt hydroxide can be reduced with hydrogen gas to produce cobalt powder. Lastly, we have manufacturing into usable forms. Metal, melted and cast into ingots, cathodes, or powder. Chemicals, cobalt salts. So I just want to backtrack. Photo 11 would be like would be the metal version of cobalt. Chemicals, cobalt salts, like cobalt sulfate or cobalt chloride are produced, important for batteries, catalysts, and pigments. Here in photo 12, I have a pigment or salt, whichever one I used. Then alloys. Cobalt is alloyed with other metals for superalloys, like jet engines or turbines, as seen in photo 13, and magnetic materials. So cobalt can be used as an alloy. In these big superalloys, it's used as like little tiny metals that help run this turbine as seen here. And with that, here are my, oh, I was really ready to stop this presentation. Anyway, disregard. So lastly, and I was trying to time this right. Lastly, the cobalt industry faces scrutiny because of environmental impacts, acid leaching and tailings, and ethical issues, child labor and artisanal mining in the Democratic Republic of Congo. Many manufacturers are working on recycling cobalt from spent lithium-ion batteries to reduce reliance on mining. So here we are lastly with that. Here are my citations. I hope you guys enjoyed the video, and I'll see you guys later. Thank you and bye-bye.